Hello everyone and welcome back to CCCS214 Object-Oriented Programming 2. Today we begin the next chapter on multithreading. So let me briefly explain what the concept of multithreading is. So you all know that most modern CPUs that you get in a PC, in a computer these days, they have more than just one single core, which means typically we have dual core processors. Four quad cores are pretty common. Some newer ones that you can get in desktops have six and even more cores inside a single CPU. Now each CPU can basically execute instructions in parallel. Now, obviously, this used to not always be this way traditionally. So, some 20 years back or so, most CPUs were still single core. But again, this is something that has changed since then. Now, the advantage, obviously, of having multiple cores in a processor is that you can run more instructions in the same amount of time. Now, if you have, let's say, three pieces of code, and so pieces of code like this are called threads. Now, if you have three different threads of code that, let's, for simplicity's sake, say they have nothing to do with each other. They do not need to talk to each other. They are independent of each other. They can all three threads, all three pieces of code can be run at the same time without interfering with each other. Then one way to doing that is, of course, by having, let's say, if we have three threads, we could have three CPUs or a CPU maybe with three cores, and we could run those three threads at the same time. So time in this case is here along the x-axis, along the horizontal direction. And so all three threads could be executed by the CPU at the same time. Now, often enough, however, that is not the case, or you might end up having more threads than you have cores or CPUs. When you have, let's say, these same three threads sharing the same CPU, what happens is that the threads have to take turns. So obviously that is slower than having a single core dedicated to each thread, but you can still execute all three threads without, say, having one thread wait for a significant period of time for a core, for a CPU to be freed up. So this is what that might look like if you have a single CPU that has to be shared among these three threads. So you have thread 1 executing for a while, then taking a pause, maybe something needs to be fed, maybe something needs to be fetched from memory or from the disk even. Something may have to be written to the disk, some time-consuming step or instruction may have to be executed, which might be a good time to hand over the control of the CPU to another thread, thread 2 for example, and the second thread can execute for a while, and maybe when it comes to such a state, it can then give up the CPU in favor of the third thread. And in this way, you can see that multiple threads can share the same CPU. Now, when you have multiple programs running on your system at the same time, that is something that the operating system takes care of for you. But let's say you might have separate pieces of code within the same application that could run at the same time if multiple cores are available. For that, you as a programmer will have to do some or make some changes to the way you write your code. And that's what this chapter is basically about. So in the Java API, we have an interface called Runnable. So in order to uh, take more control over how many threads or in order to actually divide the code of your application to multiple threads, you have to use you have to implement this interface called Runnable. So let's assume we make a class called task class. So the changes, the important portions in this code that you need to pay attention to are highlighted in yellow over here. So let's see, we have this class called task class. Now, if we have some code that we want to run as a separate thread, that code has to be put inside a method called run that is a member method of any particular class. In this example, task class. Now, if you implement this run method, that is basically the implementation of this runnable interface, and that's why we add implements runnable after task class over here when we're declaring the class. Obviously, okay, so yeah, so that's one class over here that contains some code that we want to run as a separate thread. Now, how to use this run method? How do we use that? So the name of this method that contains the code that is run as a thread, that the name of that method always has to be run, nothing else. Now, let's say we have another class over here. This one's called client, and inside we have some method, a method. Inside of that method, for example, we are creating an instance of task class called task using its constructor, and the constructor is called just like the constructor for any other class that you might create. Now, in order to execute the code inside the run method as a separate thread, what we then have to do is we have to create an instance of the thread, an object of the thread class that is also part of the Java API. That's thread with a capital T. So the object we're creating over here is thread with a small t. And as its argument to its constructor thread, we pass the object task that we created up here. And after that, all you have to do is you have to call the start method on the thread object. And what that will do underneath is it will actually create a thread that will then execute the code inside the run method of the task object that you created over here. If there are any parameters that you have to pass, if you want to control the execution of some part of the code inside the run method, you should do that through the constructor of the task class over here. Okay, so let's take a look at an example of a very simple piece of code that uses threads. So this one is called TaskThreadDemo, and I'll just briefly explain what it does. So this class implements the runnable interface, and it does three things. It'll run 3 threads. The first one prints the letter A 100 times. The second thread prints the letter B 100 times, and the third thread prints the numbers, the integers from 1 to 100. Now, all of that is happening, all of this printing is being done to screen, and all these three threads uh, will be running in parallel. We will see how that works, but so they're all printing to the screen. Now obviously we can only print one character, or actually one item, one piece of string to the screen at a time, which means that these three threads will be competing to access the terminal window on which we see the output. Let's see how that goes. So to do this, we create, first of all, so the equivalent of the task class over here is going to be first a class called print character, basically, which has to implement the runnable interface, and it has a constructor which takes two arguments: a character to be printed to screen and a number specifying how many times that character should be printed. And these two values, C and T, they're stored in these member variables of the print character class: character to print and times. And then, of course, most importantly perhaps, we need a run method. And what this run method does is very simple. There's a loop in here that runs as many times as the value stored in the member variable times, and in each iteration of the loop it prints out the character to print one time. So we'll use, remember, first thread is printing the letter A 100 times, so we'll use this print char class for that. The second thread is also printing the letter B 100 times, so we'll use another object. We'll create another object of the same class. The third one does something else. The third thread prints the integers from 1 to 100. So we need a separate class for that. This one's called print number, and it also implements runnable because it too must have a run method over here. In the constructor, in the constructor, it takes only one argument for up to which number it should print the integers, from 1 to up to whatever number. We store that in last num, the member variable last num, and the run method is very simple to the run method of the other print character class. It's just a loop, prints out the counter variable from 1 to up to last num, and that's it. So now let's take a look at the most interesting part, which is the main method. So we have this class TaskThreadDemo, which has a main method, and inside of it we create an instance of print character called print A, which is going to print character A 100 times, and another object called print B, which prints the character B 100 times. And then we have a third object called print 100, which is an object of the print num class, which will print the numbers from 1 to 100. Now remember to create a thread. Create a thread object of class thread. Call the first one thread 1, second one thread 2, third one thread 3. And in their constructors we pass the tasks that contain the objects, basically the objects that contain the run methods that we want to run in each thread. So we pass print A to the constructor of thread 1, print B to the constructor of thread 2, and print 100 to the constructor of thread 3. Now that's just the creation of the thread. We now want to start running them, and to do that we call their start methods. Call start for thread 1, start for thread 2, and start for thread 3. And that's it. Let's take a look at what the output looks like. So this is the same code over here, already created in put into already created a project in NetBeans. It's the print char class, the print num class, and the main method inside the TaskThreadDemo class. It's the exact same code. So let me execute this. There you go. That's the output. Let's take a look. So we see first a bunch of A's, then a few B's, then some more A's, some B's, then the number 1. So we switched from thread 1 to thread 2 to thread 1, thread 2, then to thread 3, then thread 2, thread 1. Now, in which order the switching is happening, that is out of our control. And it should not matter to us, because the way we have written the code right now, the 3 threads have nothing to do with each other. They're independent. We don't care which one finishes first, which one finishes second. And so you can see that the switching keeps happening. Then we see the number 2, number 3, a B, 3 A's, another 3 B's, the number 4, B, a few more A's. So thread 1 seems to be getting more of a turn in the beginning. Then we see the number 5, A, B, and lots of B's, interrupted by thread 3 that's printing the numbers. And I think then threads 1 and 2 kind of finish their jobs, they finish executing, and after that only thread 3 seems to be left and has some printing to do, and it does its job and prints the numbers up to 100, and we're done. Now, I said that we have no control over when one thread is executing and then another thread takes over. So which means that if I run the same program again for another time, for a second time, the output should look different. So let's take a look. There you go. I think I've got all A's right in the beginning, some B's, interrupted by a few numbers, but I think then the B's are also done, and then I have only task 3. I've got a few more B's left in here. All the A's definitely seem to be done, and that's it. If I do it again, I'll see a different output. There you go. I see more equitable sharing between thread 1 and thread 2. But yeah, thread 3 seems to be given least frequent access or something. Yeah, A and B, thread 1 and thread 2 finish, and we have just thread 3 left. Okay. So the thread class also contains some other methods. Thread class implements interface. The interface Runnable. It has a constructor which we just used. It has the start method which we also just used. It also has some other methods. Is alive, set priority, that we'll talk about a little later. Join, we'll talk about that a little later. The sleep method, the yield method, the interrupt method. So we'll get to those other methods that we have over here. So first off, the yield method. So inside of your code, for example, if there's some point at which you want your thread to give up control of the CPU, you can make it do that. So for example, you could add the yield method inside the for loops that we had in the print char and print num methods. So for example, here in the run method, we had this for loop, and this way we were printing out the number in the print num class. You could add the line yield, thread.yield after that, and that would force the thread to give up give up control of the CPU. You could do that. You can also basically not only just force a thread to give up control of the CPU, but give it up for at least a certain period of time. So in the same printNum class, inside the run method, for example, here inside the for loop, what you could do is after you print out a number, you could add this code in red. Try method, and if if I is greater than equal to 50, meaning that whenever you hit when you get to 50, you can call the sleep method with an argument of 1. The argument is the time period in milliseconds for which you want to give up the CPU. And this being done inside a try catch block, because calling the sleep method again can generate this interrupted exception. So Java might make you might force you to put that inside a try catch block. Another thing, this is kind of helpful if you want to synchronize the execution between different threads. So for example, you have thread 100 over the print 100 thread over here, and you have the print A thread over here. So what you could do is you could again add some code inside the run method. So thread 4. So what you could do over here, you're creating a thread, thread 4, a new thread inside the run method of printNum, which itself is running inside the print 100, the thread 3. So inside of that, you're creating another thread, thread 4, and you're creating an object of the printNum printChar class, and you're printing the character C for 40 times. And you're kicking off, you're starting the thread by calling the start method. And then you can do your own thing. Remember, this is the printNum class, the run method of the printNum class. You still have to print your own numbers. And so you do that in the loop, and when you hit 50, when you get to 50, what you want to do is you want to, by 50, you want to make sure that you do not proceed beyond that. You want to make sure that this thread 4 finishes execution before you print the number 51 to screen. So what you do there is you can call the join method on this thread 4 that you have created in here. And what that'll do is, so let's say we have time starting at the top and going downwards. So you have your print 100 thread, and you have your print. You have your thread 4. What you can do is you can simply wait for the other thread to finish by calling the join method, and then you'll proceed executing with the rest of your code. So threads can be in different states, as you know. So thread, when it's created, it is in the new state. When you call the start method, it goes into the ready state. Then when it gets when the run method of the object passed to its argument, as its argument is called, it goes into the running state, and so that's signified over here. It goes into the running state. While it is running, it you yourself might put a yield method inside it, which will put it back into the ready state. And from the ready state, at some point, it might go back into the running state. So this giving up the CPU might be managed by the OS, might be done by you calling the yield method. And basically, if everything happens normally in a simple thread, you oscillate between the running and ready state, which is what happened in the example that we just saw. And finally, you reach the end of the code inside of your run method. You finish with the loops, or the execution of the loop. When that happens, when the run method returns, your thread enters the finished state. Now, we saw a couple of other things. We saw that you can call the join method from inside the run method. You can call the join method to wait for another thread. You can do that. That takes you into one of these three blocked states. If you call the join method, it takes you to the wait for target to finish state. And when the target thread 4, in this example over here, when it does finish, the thread enters the ready state again when the target finishes, and then you continue to run and so on. There's another method called the sleep method, which we just saw, which takes you into another blocked state called wait for timeout. It's basically like the thread going to sleep and setting an alarm clock. When the alarm clock runs out, that's basically, or the timer runs out in milliseconds, you have a timeout, and your thread enters the ready state again and is ready to continue running. We also have something else called the wait method, which can be used to coordinate execution between threads, and that takes your thread into the wait to be notified state, also blocked state. And when you get out of that state, when you receive a notification method, we'll get to that a little later in this chapter, the thread again goes into the ready state. So among some of the other methods that we have is the isAlive method, which you can use to check if your thread is in the ready, blocked, or running state. If it returns a false, means that the thread hasn't even been, it's a new thread and hasn't even been created yet, or it has already finished execution. You can also call the interrupt method, which basically puts the thread into the blocked state. And to check if a thread has been interrupted, you can call the isInterrupt method to test if the thread is maybe in its specific interrupted state. Some other methods that are available are the stop method, suspend, and resume methods, but these methods, as of Java 2, these methods have been deprecated, meaning is that they're outdated, and in future versions of Java, they will not even be there anymore. So you should not use them. So instead, if you want to stop a thread right then and there, the way to do that, let's say you have a thread called thread1. If you want to stop it, don't call the stop method. Instead, just assign it the value, just assign it null, and that's it. Threads can also have different levels of priority, and you can set the priority of the thread. Higher priority means it will be given access or control of the CPU more frequently, will have more likely access to the CPU. Among the levels of priority, there's a minimum level of priority, which you can select as a macro, min_priority, and the maximum level is max_priority, and then we have a normal level called norm_priority. And here's a simple example. I'm not going to go into all the code that demonstrates the sleep method. So I'm not going to go into everything, but what I want to show you is because, and the reason is that this is an example of a piece of code that uses a window, a GUI. So it's very simple actually. You'll see this window showing the string welcome, and then it'll go to sleep, and after it wakes back after it returns after the time after it times out, the text welcome is replaced by nothing, by a null, by an empty string. And then we set the timer again, and after we come back again we change the string to welcome again, and so on. So basically we have the text welcome flash on and off. And if you don't put a timer in there, if you don't use the sleep method for that, what will happen is the text will flash at such a high frequency that you might not be able to tell that it is flashing at all. It might just flicker. So in order to make that more, in order to make sure we can see that the flashing of the text, what we're using this sleep method, and we're passing it the argument 200 milliseconds. So the text welcome will be seen for 200 milliseconds and will then, so that's 0.2 seconds, by the way. So it'll be visible for 0.2 seconds, then disappear for 0.2 seconds, then be visible again, and so on. So the set text method is called with a welcome argument. Stays like that. It's happening inside a forever loop, while true, right? While one loop. If the text is null from before, we go in here, show the welcome. If there's no text, we go into the if condition. Otherwise, it means there's some text, and the text is made to disappear, changed to the null string. Okay. Here's the code for flashing text. I'll just scroll through that in case you want to try it out. You should try it out. I'll run this. Oops. Flashing text. File. There you go. Looks a little different. That's fine. Okay. So that's a demonstration of the use of the sleep method. Also some other methods, invoke later, invoke and wait. We'll get to those. So there's an easier way to use threads than the first demo that we saw, and that is by using something called thread pools. It's basically you deciding how many threads you want to have available, how many of these. You can think of each thread as a worker. So you can create a pool of workers, a thread pool. And let me just show you how that works. So this, and we do that using a class called the Executor Service. Let me just demonstrate this to you. So So key is this executors class and the constructor new fixed thread pool, and it takes as argument the number of threads that you want to have in that pool. So let me jump to the code here, and as you'll see, this is actually slightly simpler way of doing the same thing that we did in the task thread demo. So we're still using the print character class and the print num class. Still going to do the same, print the character A 100 times, print the character B 100 times, and we want to print the numbers from 1 to 100. But see what we do before that. We create an executor service called Executor, and we pass it as argument the number 3. So we're going to create a pool of 3 threads. And we call the execute method, which is like the equivalent of the start method in each thread. We call the execute method of this executor object. So see the difference? Instead of having to create 3 thread objects over here with 3 separate lines of code, we just create one pool of 3 threads. And for each thread over here, we call the execute method of this executor object, and inside of it we're passing an object of the print char class, another one of the print char class, and the third one, the one that prints numbers, print num. And at the end of that, we have to call the shutdown method of executor, which makes sure that all the threads complete execution, reach the finished stage. So the executor service basically does not require you to think about each separate thread object. It simplifies things for us. It also simplifies starting each thread, makes sure each thread finishes execution, and so on. So let me show you what the code for this looks like. Also, there's some other things that we're not going to do, but you can do. The executor service also collects some statistics on some data on the execution of those threads that you can collect and use in your application. So let me jump over here. I have close the extra files. So for the executor demo, I put the print char and print num classes into the same project, the same code over here. Let me run this, and output should look about the same as in the TaskThreadDemo example. And here you go, we have character A, the number 1, character B a couple of times, number 2, 8, 3, 4, 5, 6, 10, 11, and so on. As you can see, this one ends with the execution of the first thread, the one that prints the character A. So looks like access to the CPU is also perhaps a bit more equitable when we use this, when we use thread pools. Because when we ran it when we were controlling each individual, when we were using raw threads, thread 1, the thread that was created and whose start method was called first, that seemed to be getting an advantage when it came to access to the CPU. Well, just ran it again, A, B, and all the numbers, not necessarily correct, I guess. And so I guess you can never really tell. So that's all about threads for now, and continue this in the next lesson.